Good evening. Take a moment and solve these two problems using the appropriate method. For the first one, use the quadratic formula. The second one, you're going to use the square root method. So pause the video and do both before we continue. Alright, so with the first one, the first thing you should have is 4 plus or minus the square root of 16, which is 4 squared, minus 4 times 1 times 13 divided by 2 times 1, which should lead you to the following. So your answer ends up being 2 plus or minus 3i once you simplify. Now with the second one, using the square root method, the first thing we need to do is add the 5 to end up with x squared is equal to 5. Then we will take the square root of both sides. So the one thing we have to be sure of when we are doing the square root method is when you write your final answer, you must have the plus or minus. Okay? So your answer is positive square root of 5 and negative square root of 5. So these answers are important is because when we have the complex numbers as solutions, we're going to have two. They're going to come in pairs. They're going to have the plus and the minus, or the negative. Okay? Which leads us to today's topic, the conjugate root theorem. Alright, so conjugate root theorem states that if we, as I indicated, if we have a complex number as a root, then the complex conjugate is also a root. Meaning, if we have the 2 plus 3i, we must also have 2 minus 3i as zeros. So if the square root of 5 is a 0, we also must have negative square root of 5. If we have 2i as a 0, we must also have negative 2i. So this only applies to the complex. So if we get x equals 3, that does not mean negative 3 is the solution. Okay, so if we look down here at the bottom, given these roots, if we have x equals 2i, that means we must also have x is equal to negative 2i. If we have x is equal to negative square root of 3, we must also have x is equal to the square root of 3. If x is equal to 8, that does not mean we have negative 8. But if we have negative 5 plus 6i, we also must have x is equal to negative 5 minus 6i. So notice this doesn't change. The negative 5, that part doesn't change. Only the 6i. So if we're looking, if we have our answers in the form of a plus bi, we have to have a minus bi. Okay? So the plus and the minus. Notice all of your quadratic formula answers are plus or minus. Okay? So pause the video and take care of number 3. Alright, so you see your answers for number 3 is x is equal to 7i and also negative square root of 5. So now, let's go next step, where we are given the zeros and we want to write the polynomial in factored form. So we know if x is equal to negative 6 is a 0, then we know one of the factors is x plus 6. So we could go x minus the square root of 5 and also x plus the square root of 5. So we're going to keep the x plus 6, but these complex roots, we're going to make their factor this quadratic factor, so being x squared minus 5. Okay, so anytime you have a square root factor, just square it and it's minus whatever that is squared. Okay. So here we have x is equal to 3i and 0. Anytime 0 is a 0, you know the factor is just x. So we could go x minus 3i and x plus 3i. But again, I want to write the quadratic factors. So we'll write it as x for our 0, and then with 3i, that comes from x squared plus 9. So when you have the imaginaries, you just have your x squared plus whatever the a portion is squared. So in this case, 3 squared is 9. Okay. Remember, when we have a double root, that just means we are squaring that factor. So if positive 4 is the 0, then that is x minus 4, and we square that factor. So having the 4i, we can write that as x squared. 4 squared is 16, so we're going to say plus 16 as the other factor. Okay, so now we want to go from the factored form to standard form, which in essence just means you have to multiply everything out. Okay, so if we have x equals negative square root of 2, we know we have x squared minus 2. If x to 0 is 3/4, remember denominator x, so 4x is positive, so we're going to say minus, the numerator being 3. So now we just have to multiply this out. So it's a binomial times a binomial, so x squared times 4x gives me 4x cubed minus 3x squared minus 8x plus 6. So in standard form, remember your exponents are going in descending order. All right, number 12, we have a double root at -1. So that's going to make the factor x plus 1, and we're going to square it. Having the 6i, that gives us the x squared plus 6 squared is 36. So that's that factor. Okay, and if you want to know why I say plus. So let's say we take the x squared plus 36 just to give you the reason. And we set that equal to 0. So that will make x squared equal negative 36, right? So now if we square root both sides, we are left with x is equal to plus or minus 6i. So that's why we always say that you can do plus and then square that factor. Okay. So from here, we have to multiply this out. So the x plus 1 squared, that essentially is x plus 1 times x plus 1. So this is going to give us a binomial times a trinomial. So we got x squared plus 2x plus 1 times x squared plus 36. So let's multiply x squared by each term and get x to the 4th plus 2x cubed plus 2x. I'm sorry, plus x squared. Oh, back that up. And now let's multiply 36 by each term. Which is going to give us plus 36x squared plus 72x plus 36. So now we just have to put our like terms together. So x to the fourth plus 2x cubed plus 37x squared plus 72x plus 36. Alright, so look at the practice problems that follow. You should do all 6 of these, then maybe the evens from everything else, and then make sure you check Schoology for the exit assignment. Make sure you get the exit assignment done prior to the end of class. Make sure to rewatch the video if necessary, and I will be back next week to answer questions. Take care.